Okay, I start again my lecture. Okay, this is the one video.
そして ADHD に苦しむ女性は他にもいた。彼女も ADHD に苦しむ一人。彼女の自宅も衣類やゴミで散乱している。その行動を見てみると、彼女が手に取ったのは電気コード。そしてこの後、驚くべき行動に出る。片付けられない彼女は電気コードを持っていても、干してあったレオタードに目が行く。
She is managing the cable, but she changed the attention, different crosses. Then put the cable here beside and managing other things. Okay. Now she's replying to the question of the children. That's why she changed the behavior. Then put this things in here. Finally, she energetically work a lot, but she temporarily changed the behavior again and again. Finally, her room is very okay. This situation unsolved. So many problems here. This is called attention deficit. Sorry. Attention deficit hyperactivity disorder called ADHD. This is the tendency. This person have the bit different autistic children, but they have the high performance in the single task. But they change their attention of the interest and the motivation frequently. The serious problem here is they easy to lose the memory. What kind of the things is done, the doing in that moment. That's why they are saying something, but they stopped on the way. This is a point, attention deficit hyperactivity disorder. This is the brain mechanism. You can see the brain, different type of the organization happening. Then you can see information by eye, retina. LGN receiving after 30 and 50 milliseconds. B1, visual cortex 1 is receiving this information. Then it's transferred to B2, B4, PIT, AIT. Then it's controlled by prefrontal cortex. Then the central motor area. Then finally, your finger is moving. This is one of the organization, how brain works from input to output. Therefore, we need to know what is the working memory is. It's a bit complicated. Now, we are single memory, like, okay, if you are hearing some voice, you can remember, you can count the number, or you can remember your friend's face or your family face. This is a single memory. But the working memory is more the connecting. Okay, what is the have the relation? What kind of the interactive things you did with others? Then quality and representation also is very important issue. So that's why we have to think about the relation, not single information, but also the representation. Okay. Okay, this is the picture. What you can see. Okay, just a moment. I just the temporarily next and your face again. The sharing here. Okay. So what you can see. Please raise your hand if you can see some animal here. What you can see. What it represents. Is there anyone find some animal from here? No? No? You can see some animal here? Yes, yes, yes. This is situation. Yes. This is the things that your brain works well. Connecting dot. Okay, this is a very simple dot, but represent something. You may see, aha, this is a dog. This. But it's totally difficult to recognize for computer. Okay, computer recognize cat and dog. If it's colored picture, it's very visible picture, but sometimes our brain can see very exactly what is this things. Okay. So what you can see. Is there anyone can understand? Okay, this is a dog. Now it's moving. That's why you can easily see this is a dog. Okay, a dog, dog, dog. So this is the hint. Even if the Google, okay, they use such a brain function. This is a hint how you can see kind of the impact messages. Okay, balance, dominance, or shape and contrast color, negative space. This is called the Gestalt phenomenon. So it is called closure, proximity, continuation, the finger on the ground. You can easily read this spell, Gestalt, G-E-S-T-A-L-T, because even if there is a blank, you can spare, okay, this is connecting, G's appear here. This is the E, even if it's black and gray. It should be E. This is the back side button should be F. This is the pattern. These T and T very similar. You can easily find. And then, even if there is no letter here, but then you can see, this is a gestalt. That's why it should be A, even if there is some lack of the information. This is a gestalt phenomenon, how your brain works well. Okay, this is the 5A, proximity. Sometimes the information use this kind of structure, highlighting, then impress express the information, then you have motivated to see in the commercial. This is the law of similarity. You can easily see square, circle, square, circle. That's why you can see this vertical bar. That's why some of the commercial or the message can easily see, this is a group of the information, something. Then, this is a law of closure. You can easily see triangle this way. Okay? Then, you can see, this is a panda. This is the apple. This is the things. This is the law of the continuity. It's connecting. That's why you can easily see IBM. This is the things. Figure on the ground, you can see basin in the white shape, but also you can see face. This is the one person here. Then you can see it's very invisible, but this is iPhone, it's better here. Then you can try to see. This is a kind of trick of how big company try to get your attention. This is the things, the mechanism within information and representation. What do it represent? Information itself, just a black and white dot. Okay, like this. But representation, this is panda. It's a representation, not anymore black and white picture. This is again movies. Jumping, very amazing, because once the fish is jumping, they cannot control their own body anymore. But he can get the insect here. So again, I'm saying here, opera analogy. Yes, but jumping together, touching the leaf. This is the egg. But the Amazonian forest very sunshine is very hot. That's why it's drying and drying and drying. That's why they are quite concerned about their own children. Finally, they put water again and again until they are hatching. So my question is, how such a tiny brain can think about their concerning about egg, okay? Then action and cognition have loops. Then some awareness exists. They know what they are. This is the power of the natural property of the living system. Not simple robot, not simple artificial intelligence. This is the point I'm explaining here. What is the difference the machine and the animal? So this is a monkey. Monkey is very, very smart. I also visited the one temple in India. And there are so many monkeys behaving like this. But this is a monkey a bit special. They can use the rock. They get nuts inside the herd shell. This is the Ashimo. You may know if you're coming in Japan, you can see the robot. In fact, people are very kind for robot. If people are so surprising to see the robot, oh, robot is coming, I mean, something like that. But if they are person, you say many complain. Oh, I'm really waiting for my chai or the coffee. Please bring it earlier, something like that. Oh, now I ordering this food, not this. You can say many complaints to people. Yes, computer, machine, rule-based implementation, designed by the external programmer. Rules should be consistent. If there is a contradiction inside the rule, computer program stops. It's a you call bug. But we are so intuitive. So many ideas coming from inside. Oh, I got idea. Oh, I got idea. I got idea. Then you can think a lot. That's why, okay, we are so self-referential. You can think about yourself. I did bit serious mistake. That's why I'm wrong. Then you can think about yourself. Then you can improve. That's why it's self-reinvention. Okay, you can change yourself. If you do the same thing in your computer, like change of the operating system one by one, okay, computer stop. That's why biological system very flexible. My motivation here. Yes, robot control is very tough. It's very difficult. You can design. You need to design accurate motion control, object recognition, matching object with implement to target, blah blah blah. It's very tough. This is the refrigerator and robot. If you design very fine robot to grab such a drink by hand, oh, that's amazing. But okay, this is a hot day today. That's why this cold drink is good for my master. Robot cannot think that kind of thing. That's why this is still difficult things for robot and artificial intelligence. Yes, this is the hierarchy. What you think usually in the daytime, okay? If you go to the school or working in the office, this is the concept level. But it's decomposed, the different types of concept of the information. If you want to go to work or go to school, once you need to go out home, home. Drive a car or catch a train, this is the next thing. If you're working in the office, check today's email or plan, but it's also decomposed. Okay, check email means type the keyword, print document, something. It's very primitive action. But you're managing that this kind of thing is parallelly. You can imagine now I'm working. That's why I'm checking email. That's why I'm typing. Consciously or unconsciously. This is the hierarchy that your brain works. Okay. This is the organization. What kind of the information representation done in your brain? Sometimes go out of home or drive a car or to office is inside the group that go to work. Or even you go in shopping, similar kind of item is inside the same group. That's why it's quite complicated. Sometimes you need to behave to go home is the driving a car or catch a train, they're riding the bicycle, different combination. The single concepts like working, shopping, studying is decomposed different primitives. You can realize, okay, this is the key for locking. This is the bicycle I'm riding. Individual information you have to recognize. Then connect them together. Oh, I'm going to school. That's why I'm riding the bicycle, something like that. This is a decomposition process, different items. And this is a composition process you can build. What you represent now in brain. Okay. This is the point to know what I'm doing. Yes, some technical things, you try to grab some things by visual recognition, motor control, like a fish. But also you can think, oh, what is this? Recognition, what I'm intend. Oh, yes, I'm studying, that's why I have to grab pencil. This is the two layer. Top-down the information is coming, recognition what I'm intend. Then skill, how you can drive the car, the bicycle, or playing piano is coming from skill. This is matching together. That's why you can aware, oh, I'm doing this. I'm recognizing this. That's why I'm doing this action. This is the two information process your brain do. So this is the point. The robotics people are saying about their embodiment. Firstly, they are thinking about central nervous system may be important, but difficult to reconstruct. That's why I'm making this robot. If we are working robot, it's very simple. To reproduce this. That's why mechanical system and sensor feedback and task connect them together. That's why this robot can work. This is the post-brain problem. It's called affordance, situated cognition, embodiment, environment connects agent. That's why it behaves. This is the traditional theory called embodiment, highlighted in the 90s. That's why Rolf Pfeiffer, Professor Rolf Pfeiffer, I met last month in the special lecture in the QTech. And he is discussing about their embodiment, finally. This is one example, morphological computation. If you can try to reproduce the mass activity like dog, it's a bit complicated. If you try to design some humanoid robot, very specific calculation, bit tough. That's why some people try to reproduce a kind of the function to reproduce similar kind of the behavior by simple mechanism. This is a morphological computation. That's why the embodiment people are saying analysis is difficult. That's why they try to rebuild in real world. That's the things the kind of the evolutionary process in the brain. But I disagree. Because of the brain damage have the serious the deficit of your function. Yes, you can focus on walking or some jumping, some specific function by robot, but we are so bit more complicated. We can change jump, run, walk flexibly. That's why central nervous system really needs to organize what you're doing now. That's the point. Yes, Professor Lord Pfeiffer saying the okay, brain is not so serious, but now I'm thinking about that the hierarchical the computation, how you are doing. I'm studying, that's why I'm learning this, that's why I'm receiving this lecture, something else. Your intention, your motivation is very important. We are not just a simple robot. We are not slave. We are intelligent. That's why we are thinking about with specific intention. This is a development, the locomotion and the cognition. There are some different types of time scale. Your neuron fired 1 millisecond, for example. Short-term memory works well, second 2 minutes. Long-term memory, you can remember what you did last year. This is a different time scale. Your brain works well. And simultaneously, we have two types of the memory, explicit memory and implicit memory. Okay? How do you can drive or riding a bicycle? Once you have training the riding a bicycle, you can ride the bicycle easily if you are thinking about another thing. This is a kind of motor control learning. That's why implicit memory. You cannot explain why you can ride the bicycle, but you can ride. That's why you can have memory, but implicit way, not consciously. But sometimes you can remember what you ate yesterday, who you met last month, family or friend. Then you can have the personal history according to the memory. This is the called explicit memory. You consciously access your past memory, then you can remember, then explain to other person. This is the explicit memory. This is the problem. Autistic children cannot understand what they're happening. We try to steer information. Oh, this is playing or pushing. No, it's a fighting. This is the kind of picture. Yellow is the chasing. Oh, just a splitting picture, but you can imagine what it behaves. This is also too. This is the point why working memory is very important. then brain-machine issue is the meaningful. That's why Gestalt phenomenon is called binding problem. How you can bind different type of the input, then connect them together to represent one specific meaning. It's the same thing. You need to control the motion. This is called problem of the degree of freedom. Some assisted robotics is really neat. How you can behave attaching it to the devices. This is called assistive robotics. People can make this kind of robot by printing by 3D printer or cable. It's very easy to make now. Then by measurement, muscle activity or brain activity.
それぞれの個性を抱えながら社会的存在となる道を歩みます。他者と生きることを学ぶ第一歩は親との人間関係。2歳前後になるとごっこ遊びの段階に入ります。さらに大きな喜びをもたらすのは友人を作り関係を持続する能力です。分け合いや協力を学ぶのは
So this is a social activity. This girl, today is the birthday of her. That's why the mother prepared big chocolate cake.
キアラは2歳の誕生日を祝おうとしています。あら、聞こえた？ドアに誰か来たわ。
So mother is going to the guest. He said, please don't touch chocolate cake. Okay? Don't eat. But she's very, very interested to eat chocolate cake. Now she's decorating chocolate cake. But occasionally, her finger attach chocolate. That's why she's cleaning up her finger, not eating. Okay? She's saying, oh, this is decorating, not eating. Just occasionally, my finger is the dirty. That's why I'm cleaning. So then mother coming back again. So then she's saying, oh, you ate this? I said you do not eat chocolate cake. But she's explaining, no, I'm decorating, just decorating. Okay? This is some kind of social behavior. How children learn, such as sociality, how they can communicate. They have a lot of motivation. It's very interesting in the box inside, but this trainer say, okay, please don't touch. Please don't touch. Now she's fighting their own mind. She's very interested in to see the box, but this guy it cannot stop their own mind, okay, to see the box. This guy is very rude to see immediately. So they are frustrating to see what
この実
inside.
験の結果、自制の能力は年齢と個人の成熟度によって左右されることが分かりました。性別もまた無視できません。
It totally depends on,
男の子より
depend on the okay, he got it. Okay. this is a situation how they can keep their own mind against their own motivation or their the interest. Okay, this is also the difference of what kind of blame function here. These are culture. The difference again, I can see the after that more the after your feedback. Okay. So again, I would like to close second lecture today.